All right, section 15.5, we're going to be talking about parametric surfaces. So we've already talked a decent amount about parametric curves, which if you remember, there's different ways of representing them. So for example, a parametric curve in space could be represented by a vector valued function. So we can do like x of ti, y of tj, and z of tk, where say t runs from a to b. You could also instead represent that with just a set of parametric equations. So like x equals x of t, y equals y of t, and z equals z of t, representing the points that make up that curve. Now what we're going to do is consider parametric surfaces. Now the difference with parametric surfaces is rather than just one parameter like t, we're going to have two parameters. So common choice is a u and v. You could even just use an x and y. Really, you just need two of them. So what this is going to then look like is a multi-variable vector value function. So we're going to have like r of uv. So this is going to be some x components. We would have like x of uv all times I. We would have plus y of uv, say all times j. And we would have plus like a z of uv all times k. So basically three components that are all two variable functions of these parameters. So then we would have some range on u, so say u goes from a to b, and then v goes on some other range like c to d. With the same way we did with parametric curves, we could also do parametric surfaces just with parametric equations. So we could just instead say x is, say that x of uv, y is y of uv, and z is z of uv, where again we've got those ranges. U, say, goes from a to b, and v from c to d. So the difference is just kind of how we're storing the information. In this one, we're tracing out the points as the terminal point of those vectors as they trace with their initial point at the origin. So those vectors kind of trace the points on the surface. Versus with this one, we set it up where my x, y, and z would then be the points of the surface. So what we're going to do next is just take a look at some examples. We're going to use Maple to see some examples of parametric surfaces. One of the really nice things about parametric surfaces, similar to when we had parametric curves, is it gives us a simpler way of describing surfaces that aren't necessarily functions. So we've already looked at lots of examples of surfaces that are functions, like z is a function of x and y, but we can also look at lots of examples where I can have a fairly simple parameterization that then represents a surface, which is not a function of one of the variables in terms of the other two. So we'll look at that next.